For this barbershop business was growing fast. Customers were coming in every day, bookings were increasing, and money was flowing through the business. But there was one major problem. Nobody actually understood what was happening behind the scenes. The owner couldn't answer simple business questions like, which barber makes the most money, which branch is busiest, or even which services customers loved the most. The business had data, but no real visibility. As the barbershop business grew, so did the chaos. Excel files were scattered everywhere. Some reports were saved as CSV files, others were exported as JSON. Different employees had different versions of the same report. Nobody knew which file was the latest anymore. One spreadsheet said revenue was increasing, another said bookings were dropping, and every time management needed answers, the confusion only got worse. The business was drowning in data, but starving for insights. That's when the data engineer stepped in. Instead of relying on disconnected spreadsheets and manual reporting, the plan was simple. Organize the data, clean the inconsistencies, and build a proper data pipeline. The goal wasn't just to move data around. It was to transform messy business data into something reliable, structured, and useful for decision-making. The first step was understanding where the data came from. Bookings, payments, customers, services, and branch information all existed in different systems. Using an ETL pipeline extract, transform, and load, the raw data could now be collected, cleaned, standardized, and modeled into a proper data warehouse. Duplicates were removed. Missing values were fixed, business rules were applied, and slowly the messy data started becoming trusted information. After organizing the data and building the pipeline, everything finally started making sense. Now the business could clearly see which barber generated the most revenue, which branch performed best, what time customers booked the most, and which services were driving growth. What used to be spreadsheet chaos was now transformed into clean dashboards and real business insights. And this is the true purpose of data engineering, turning raw data into decisions that help businesses grow.
All right, so before we write any code, the first thing that I always like to do is to create a proper GitHub repo for the project. So that's what we're going to be doing in this video. We're going to create our repo, click on the create new repo, give your repo a name, give it a good description. And I'm not going to initialize with the README file or a gitignore file from GitHub, because I want to create and manage those files locally myself. That gives us full control of the project right from the beginning. So let's do that. So now that the repo is created, I'm going to copy the repo URL and clone it locally into VS Code. So once this folder is cloned, this is now basically our working project environment. From here, we can start organizing everything properly. So create your folder locally and then open the command prompt and then choose or type git clone, and then you paste your URL from there, and then you need to clone your remote repo into your local. So the first file I usually create is the readme.md file. This is important because it explains what the project is about, the problem we are solving, the architecture, then eventually how someone else can run the project. So we're going to give our project title, Barbershop Analytics Pipeline. And then what is the goal of the project? So basically is to turn raw CSV files for the barbershop into a clean data warehouse style schema that can be used by downstream applications like your BI reporting, Power BI. The tech stack that we're going to be using is Python, SQL Server, Power BI, Git, and GitHub. This is all beginner friendly, guys, so don't intend to go deep into these things. We're going to turn our raw CSV files into a clean structured format ready for BI reporting. So next I'm going to create a .gitignore file. So this file basically helps us avoid pushing unnecessary files into GitHub. So things like your virtual environments, your cache files, your secrets, API keys, that shouldn't be part of the source control, right? So honestly, setting this up properly at the beginning saves a lot of pain later when the project starts growing. So now that we have created our files, Git is already tracking that something has changed inside the project, right? So the first command I usually run is to run a Git status to see what has changed. So what this does is basically give us a quick health check of the repo. It shows which files were added, modified, deleted, or whether Git is currently tracking them or not. So right now, the gitignore and the readme files are showing untracked. So the next step is to basically add them. So we click, we add git add dot, which basically adds all the files. So you can think of it like placing files into your staging area before taking a picture of the project. And then we run a git commit, which basically it's a saved checkpoint of the project at a specific point in time. We are going to create tags as well. Tags are useful because they let us mark important milestones in the project repo. So I've taken mine milestone 01 Git project setup. We're going to push git push takes our local commits and uploads to the remote GitHub repo, so they are backed up online and available for collaboration, right? So we're also going to push the tag as well, so that you can see that this is the milestone that we've actually completed. Okay, so now that we have introduced the problem and set up the Git repo, the next thing I want to do is to organize the project structure properly. So inside VS Code, I'm creating the data raw folder. This is where all our raw source files are going to live. And for this beginner project, we have 6 CSV files representing the different business entities in the barbershop. So we have the barber CSV, bookings, branches, customers, payments, and services. At this stage, we are treating these CSV files as if they're coming from different operational systems in the real world. So instead of jumping straight into the dashboards, we first need to think like data engineers and ask, how do we organize and process this data properly? Now, one thing I always like doing early in the project is creating the project's notes.md file. This looks simple, but it's actually very important habit in real world projects because documentation helps us clearly define the problem, the available data sources, and the questions the business wants answered, right? I'm going to demonstrate what happens when I comment the .ignore file rule, right? So when I comment it out, notice how Git suddenly starts striking the CSV files again. And then once I uncomment the rule, Git stops striking them. This is really good beginner concept to understand because many people accidentally push large data sets into GitHub repo without realizing it. So finally, now everything looks good. I'm going to stage the files using the git add, create my commit, push everything to GitHub. At this point, our project foundation is officially set and ready for us to start building the actual data pipeline. Okay, so now that our raw files are ready in VS Code, before we can do any analysis or anything at all, we first need somewhere to store that data because we're going to be moving the data from CSVs into the bronze layer. So we need to create a database. So now there are actually multiple ways of creating a database. You can either use the UI, you just right click on database, you specify your database name, and then you click OK. But this is not scalable. What you need is to run this as a script. So I'm going to use the create database, and then I specify the barbershop or the database name, which is barbershop analytics. This way is mostly preferred in production systems because scripts are easier to manage, they're easier to version control. You can also share with the team. You can rerun them later on instead of just clicking on buttons, right? So now inside the database, we are creating schemas for bronze, staging, and the DW. So schemas are basically just a way of organizing objects inside the database. Think of it like folders on your laptop, right? So instead of having multiple tables mixed together, you can logically separate your objects into different folders in a clean way. So you'll notice that now if I rerun the create schema statement, it fails because the schema already exists. And this is something we want to avoid in real production systems because deployment scripts get rerun all the time. We want our scripts to be idempotent, meaning I should be able to run them multiple times without any errors, without breaking the system, without a change in output. So that's why I have to then implement a check before I actually create the schema. So you'll see that the schemas are actually created under security. Then under schemas, you'll see the 3 schemas that we've created there. And then next we are going to start creating the bronze raw tables. So the same concept that we have for schema. If the table already exists and we run the script, SQL Server throws an error. So we want to counter for that. So we're going to use an object ID to check whether the table already exists before creating it. So object ID basically returns a unique identifier. So if a table object already exists, then it will return a number for that. If it doesn't, then it becomes null. So we're going to do a check to actually see if an object actually exists. Now in the bronze layer, almost every column is stored as a varchar or varchar. And this is very intentional because in this stage, we're not trying to clean or trying to massage or validate the data yet. No. For example, the booking amount comes in as text instead of a number, or maybe dates arrive in different formats. So we don't want to fail the ingestion because of that. So bronze will preserve the raw source data exactly as it arrived. The only extra columns we are adding are things like source file name and loaded at. These will help us track where the data came from and when it was loaded into the system. This becomes very useful when you're trying to troubleshoot the pipeline later on. So to save a bit of time, I've already pasted the remaining bronze table DDL since the pattern is exactly the same for the other tables. Yeah, so then we paste the DDL in the create table SQL file, and you guys already know the drill, right? So we do a git status. We see that create table SQL is the only untracked file. We add that specific file, and then we commit. After committing, we'll then push that to the repo, and we also create a tag for that. So now, before we start writing the ingestion logic, I'm going to create a .env file. So this is a file that is used to store configuration values outside the code itself. So things like your SQL Server, your database name, your driver, your username, your passwords. This is considered best practice because we don't want sensitive information hard-coded directly into our Python scripts. So it makes the project easier to move between environments as well. So for example, I move from one local machine to another server. I can simply update the .env file values without actually changing the actual code. Now that the configuration is set, we can start building the ingestion Python script. So we're going to use the OS module to get those environment variables from the .env file. And then we define the dictionary that consists of the file path and the target table name. So we're going to be reading the data from the raw folder. For each of those files, we write to a corresponding target file in the bronze layer. So the basic goal of the script is very simple. Take the raw CSV files and load them into the bronze tables. But one important thing to notice is that the columns in our CSV files are exactly the same as the columns in our bronze tables. The only difference is that in bronze we added two extra columns. That's the source file name and the loaded at. The requirements.txt file is used to basically keep track of all the Python packages that are used or the project depends on. So in this example, we've got pandas, we've got pyodbc and python.env. So this is very crucial because when sharing projects with other developers, everyone can recreate the same environments easily. And now I'm going to do a pip installation of that, and it failed because of the wrong spelling of Python and also of requirements.txt. So I'm going to query the bronze tables to show you that they're currently empty before I run the ingestion script. So as you can see, we do have data now populated in our database. You can check the current time the rows were added. So in this section, we added 3 files. That's the .env, the load bronze, and the requirements.txt file. But you can only see that I only have 2 files that are untracked. This is because the .env file was added to the .gitignore file. So Git won't be tracking that. So that's why we have only 2 files that are untracked. So as you can see here, we have added the loadbronze.py file and we are ready to go. So earlier, our bronze layer was simply storing the raw CSV file data exactly as it came in from the source files. Okay, so we intentionally kept bronze very close to the source because the goal of bronze is basically for traceability and raw historical storage. But the raw data itself is usually not ready for reporting or analytics. So now we're going to move into the staging layer. This is where the real transformation work starts happening. In the staging layer, we begin the data cleaning, we standardize the values, we convert data types, and create business-friendly columns that will make analytics much more easier later on. So you'll notice that in the staging tables now, we have proper SQL data types, like your date, your integer. This is very important because in the raw CSV files, everything basically arrives as text. So here we need the staging tables to be idempotent when we run the script. So we're going to use a check to see if the table already exists or not. So for analytics and reporting, SQL Server needs to understand what is the date, what is the number, what is currency, and what is a proper integer value. So we're also adding additional business columns that did not exist directly in the source files. For example, full name, as you can see here, region, duration buckets. These are the kinds of transformations data engineers often keep to make reporting easier and more business friendly. For this beginner project, we're using a full load approach. That means every time the pipeline runs, we first drop the staging tables and then we reload all the data again from bronze. A full load is much easier to understand when learning data engineering, but later on we're going to introduce more advanced concepts like incremental loading. Okay, so now that the staging tables are created, the next thing is to load data into them. So for this particular project, we are using a very simple approach, and it's very common and called full load. So the first thing that I'm going to do is to use the truncate table. So every time when I load the data, I first clear all the existing data in the staging table before we reload it again. So we keep the logic very simple because every pipeline runs starts from the clean staging layer, right? So later on, we're going to advance this project. We're going to implement incremental loading. So we only process new or change records instead of loading everything. So after truncating the table, we then use an insert into statement. But one very important thing to understand here is the columns listed in the insert into section, they must always align correctly with the columns coming from the select statement below, because SQL inserts data positionally. So if the order is incorrect, you can accidentally load the wrong values into the wrong columns, basically, yeah. So keeping the column order aligned is extremely important in ETL and data engineering work. Inside the select statement is where most of the transformation logic happens. This is where we start cleaning and standardizing the raw data before loading it into the staging. You will notice I'm going to be using several SQL functions throughout the scripts. For example, I'm using trim. This removes unwanted spaces from the beginning or and the end of values because raw source files often contain messy white space issues, right? All right, I'm also using upper and lower. These help standardize text values. So let's say, for example, we've got our customer ID and branch codes. This should always have consistent casing, so joins and any matching logic that we need to work correctly later on. We then have the nullif. This converts empty strings into actual null values because sometimes source systems send blank values instead of proper nulls. After that, I'm using a coalesce function. This helps us replace missing values with controlled defaults like unknown or any other value that you'd want to use. We also use the try convert quite a lot. This safely converts text values into proper SQL data types like your date, datetime to decimal and int. The reason I prefer try convert instead of just a convert is because if SQL encounters a bad value, for instance, the pipeline will want completely fail immediately. Instead, invalid values simply become nulls, which is much safer for ingestion pipelines. You also notice several case when statements. These are being used to create business-friendly logic. For example, let's say categorizing booking times into morning, afternoon, and evening, grouping service prices into budget, standard, or premium, and grouping payments into cash or digital. This is a very common pattern in staging and transformation layers because we are preparing the data for reporting and analytics. And finally, notice how we are also carrying forward the metadata columns like your source file name and the loaded at. These are extremely useful for traceability and auditing. If something goes wrong later on, we can always identify which file the record came from and when it was loaded into the system. So overall, the loading script is where our bronze data officially starts becoming structured, standardized, and analytics ready. So I'm going to load the other tables as well, since the logic almost looks the same, but it's just for different tables. So you can follow along and see what we did there. So now in VS Code, we're going to create a file, load staging.sql file, which is going to contain the script for creating those, for ingesting those files into the tables. Now we're moving into one of the most important sections of the project, the star schema. Up to this point, we have loaded raw data in bronze and then cleaned and standardized it in staging. But staging tables are still not the final reporting model. They are clean, but they're not yet optimized for analytics. So now we move into the data warehouse layer where we organize the data into facts and dimensions. This is called a star schema. The idea is very simple. At the center, we have a fact table. The fact table stores the measurable business event. In our case, that event will be a booking. Around the fact table, we have dimension tables. Dimension tables describe the events. So for a booking, we want to know who the customer was, which barber saved them, which branch it happened at, which service was booked, and what date it happened. That is why we create dimension tables like your dim customer, dim barber, dim branch, dim service, and dim date. Now I'm starting with the dim customer. You'll notice the first column is customer key, int identity 11. This is called a surrogate key, and it basically automatically gives us values. The first one is a seed, which means all the values start from 1. And then the second one is the increment. So it will increment by 1 every time it assigns a new row into the table. Customer ID is the natural key or business key from the original source system. So the difference is customer ID tells us who the customer was in the source data, and customer key is the internal warehouse key we use for joins in our reporting model. This is a very important data warehousing concept. Instead of joining our fact table directly to the source keys like your customer ID, barber code, we join using the surrogate keys, which are customer key, barber key, and service key. This makes the model more stable and easier to manage over time. So before we build the fact table, we also need to define the grade. The grade means what does one row in the fact table represent. For this project, one row in our fact table will represent one event booking. That means every measure in the fact table should make sense at the booking level. So one customer booking at one branch for one service at one point in time. Now, another important thing we are adding is what we call ghost records or unknown dimension records. In real world data, not every record is perfect. Sometimes the booking may not have a barber code. Sometimes the customer value may not match exactly or anything in the customer dimension. Instead of leaving these foreign keys as now, we create a special unknown record in each dimension. Usually this uses a key like -1. So later when we load the fact table, any missing or unmatched values can point to the unknown record. This will keep our fact table clean, avoids any broken joins, and making data visible in the reporting layer instead of hiding it. So as I create the rest of the dimensions, the pattern is mostly the same thing. When you see the red squiggly lines, you can basically go to Edit, IntelliSense, and refresh local cache to actually remove those squiggly lines. So now that the dimension tables are created, the next step is to load data into them. So for this beginner project, I'm using the same full load approach. So first I truncate the dimension table. This clears the existing records so we can reload the dimension from the cleaned staging data. Then I insert the records from the staging into the dimension. One important thing to notice is that I'm not including customer key in the normal insert statement. This is because customer key is an identity column. SQL Server automatically generates this value for us, starting from 1 and increasing by 1 for each new row. So we only insert the business columns like your customer ID, full name, gender, city, province, and the other descriptive fields. The warehouse takes care of generating the surrogate key. But there is one special exception, the unknown record. For the unknown record or unknown customer, I want the customer key to be -1. This is why I temporarily turn identity insert to on. That allows me to manually insert a value into the identity column. After inserting the unknown row, I turn identity insert off again. This part is very important because for all the normal customer records, SQL Server should go back to generating the keys automatically. And we follow the same pattern for all the other dimensions as well. So now we can see the unknown cost record has been populated. It's the first one with the -1. Now, once the dimensions are loaded, we can populate the fact table. This is where everything comes together. The fact table is loaded from staging booking data, but instead of storing raw business keys like your customer ID, your barber code, or service code, we join the dimensions to the dimension tables and bring in the surrogate keys. So for example, we left join bookings to dim customer using customer ID, and then we store customer key in the fact table. We do the same for barber, branch, service, and date. I'm using left join here intentionally. The reason is that I don't want to lose any booking records just because one dimension value is missing or does not match. If the customer, barber, service, or branch is missing, we still keep the booking in the fact table. And when there is no match, we use the unknown key, usually -1. This keeps the fact table complete while still making data quality issues visible and reporting. So the big idea here is dimensions describe the business context, the fact table stores the measurable events, and the surrogate keys connect everything together in a clean star schema. Here we have our fact table. So the next thing is basically to commit the code that we have to GitHub. So up to this point, we have been running SQL scripts manually. That is okay while learning because it helps us understand each step clearly. But in real data engineering projects, we don't want to manually run scripts one by one every time. We want a repeatable pipeline. So now we're introducing Python as the orchestrator. The important thing here is SQL is still doing the actual transformations. Python is not replacing SQL. So Python is simply controlling the order of execution. So our pipeline order is we're going to first load staging and then load the data warehouse dimensions and then load the fact bookings. So I'm creating a run SQL script Python file. Inside this file, I first load the database connection settings from the .env file. Then I create a reusable get connection function using the pyodbc. This allows Python to connect to SQL Server. Next, I create the run SQL script. This function opens the SQL file, reads the contents, splits into batches, execute each batch against SQL Server. So instead of copying and pasting SQL manually, Python can now run the full script for us. I'm going to create a helper function called split SQL batches. This is important because SQL Server scripts often use the Go keyword, but Go is not actually SQL. So it is a batch separator used by tools like SSMS. So when we run SQL from Python, we need to split the scripts into a separate batch ourselves. That is what the function will be doing. After that, I create the main.py file. This becomes the entry point for the pipeline. So now instead of manually running bronze and then staging, then dimensions, then facts, I can run one command. Python will execute the pipeline steps in the correct order, first with bronze and then loading staging tables, then data warehouse dimensions, and then finally the fact table. At this point, the project starts behaving more like a real pipeline. But while testing, I noticed something important. Because the bronze script was inserting data every time, rerunning the main.py caused duplicate rows in the bronze tables. And this is actually a great learning moment. Pipeline should be repeatable. If I run it once and then run it again with the same source files, I should not accidentally double my data, right? So to fix that, I'm going to add a truncate table function. So this function clears the bronze table before loading the CSV file again. Then inside the bronze loading process, I call the truncate table function before inserting the data. Now, when I rerun the pipeline, the bronze tables are refreshed instead of being duplicated. So the final flow is now much cleaner. So we still have duplicates, and we have 180 rows in the barber's row. So I'm going to now rerun the script again multiple times to see if the duplicates are actually taken care of. Now you can see I don't have any duplicates in the table, and I've got 36 rows. I'm going to run it again. You can see I still don't have any duplicates. So this means it's now truncating the table before inserting the new record. So it becomes idempotent. So now we're looking at the final outcome of the entire pipeline inside Power BI. Remember, we started with raw CSV files that were disconnected and difficult to analyze. For example, you can now see who is the top performing barber is based on revenue. You can even dynamically switch between the top end and the bottom end barbers to compare the performance. We can also analyze what time of the day has the most bookings, which helps the business understand peak operating hours. We can see which branches are the busiest, which services are the most popular, and how different regions are performing. Because we created a proper date dimension, we can also filter by date, analyze revenue trend over time. And once published, we can see the exact same analytics available in the cloud. So at this point, we have completed a full beginner end-to-end data engineering project. We started with raw files, built bronze, staging, and data warehouse layers, created a star schema, orchestrated the pipeline with Python, and finally delivered analytics through Power BI. In future videos, we'll rebuild the same project using platforms like Microsoft Fabric and Databricks to show how the exact same data engineering concepts apply across different platforms. Now, in this project, we have built a few basic dashboards to answer some of the main business questions, but there's actually a lot more insights you can extract from this data. You could explore customer retention, repeat customers, service combinations. So I would definitely encourage you to keep experimenting and try to build your own additional insights on top of the warehouse model we created. If you do build something interesting, feel free to share it on LinkedIn, tag me. I would genuinely love to see what you come up with.